Welcome back to another FPS game tutorial. It was a long time when I last made an FPS game, so I thought it would be a good time for that. And actually, as you can see, I have added a few improvements to the FPS game, like the particle effect, as you have shown earlier. So when I shoot, the particles came out from the barrel of the weapon. And if you shoot something, for example, shoot this wall, as you can see, there is another particle effect right there when the wall is shot. And also the bullet impact, which is basically just little quads on the image, on the surface. So little quads, and there is an image on them, and I just place it in there. And if the collision planes are perfectly placed, then they look like if they are actually impact on the wall. It's work with any wall, although as you can see, this wall is actually not this collision plane is not perfectly placed. Anyway, so it's work with any surface. You can shoot the so you can shoot anything and there will be these bullet impacts, although the collision planes are not perfectly placed in my game, so it might be not perfect. And as you can see, we can now with the collision impact see how the weapon actually shoots. And if I am aiming, so let me go here, if I am aiming, as you can see, the bullet impact, but the bullet are almost perfectly goes to the same place. Alright, what else? As you can see, I have tried to work with the collision plane, so make the collision more perfect. Instead of putting a sphere around the zombie, now you can see actually the collision planes and the normal vectors. The green are the normal vectors and the red are the collision planes. And if I shoot, for example, the chest, then if I go here to the terminal, if I can find one, as you can see, it's right chest shot. But if I can shoot the head about there, and let me go back to the terminal, as you can see, it's headshot, although it does work, but I'm afraid it's not perfectly. So for example, when I shoot next to the zombie, for some reason, and I can't figure out why, it still gives it as a shot, and I don't know why it gives as an arm shot. And as you can see, I'm perfectly shooting next to the arm, so I have no idea why is this happening. Maybe I will try to go through the code. I just rendered out the collision planes, so I can see that where are the collision planes, and I can't understand why is this happening. As you can see, still for some reason, I don't know why. So I will not show you this trick right here. You can find it on the source code. I would appreciate if you could find it. Alright, so I can shoot it, and as you can see, there is a blood effect as well. This is a particle system as well. So I have added 4 particle systems. One is for the fire, as you can see. The other is for the impact. The other is for the blood, you can see blood, and the last is, for example, the grenade, the frag grenade. So I can drop a grenade, and where is my grenade? It usually works. Let me try to rerun the program. So grenade, I don't know what happened. I think it fell through the map. As you can see, this is the 4th particle effect. What else did I add? I added walking sound, so let me just kill this zombie quickly. And now if I just give a little sound and I hold the microphone a little bit closer to the speaker, as you can see, there are sounds. So when I walk different surface, it has different walking sound. Actually, it's ripped from Minecraft. And also I had added a collision detection improvement, so now I can go up to the surface which has the angle less than a specific threshold. For example, this surface is 10 degrees from the XZ plane. This is 20%, and as you can see, I can still go up here. This is 30%, still I can go up there. And this last one is 40%, and as you can see, I can't really go up. I can jump, but I can't really go up. So I try to go up, but I cannot because it's too big. So if I just release the mouse, as you can release the keys, as you can see, I basically just slide down on the hill. And this is exactly what we wanted. It is a fairly easily achievable effect, so not effect, algorithm in the sphere plane algorithm. Anyway, so I guess you are not here for update on the FPS game. Oh, and also I added sound system, you already heard that. So there are sounds for shooting, the zombies giving sound, and the walking sound. These are the sounds which I'm currently added. Okay, so this was all. Let me go to the coding. this tutorial is not actually structured as well as the others, so there is not a specific subject which I want to cover, but actually a lot of little subjects. So let me just open up the last project from our FPS game. Here it is. I believe this is it. Okay, and let me just go, for example, the game.cpp. And there were a few little bugs I wanted to fix those as well. So, for example, here I found the bug that I forget to use the if is online, only I delete the network if we were online, because if we were not online, the net is actually an uninitialized variable. So, if is online, then I delete the network. Okay, and actually it sometimes happened, if I remember correctly, that the weapon for the player doesn't actually show up, and that's actually because I forget to initialize the isWeapon variable. I think so. I'm not sure. I thought that the boolean has an automatic initialization of false, but it seems that I was wrong. Anyways, but if we manually initialize the isWeapon to false, that should solve this small issue. Alright, then actually let me make that collision you saw, so I can walk up the hills if the angle of the hill is in a specific threshold. So let me just open up the collision.cpp file and actually the collision.h file as well. And let me just search for the sphere plane algorithm. I believe this is in here, as you can see down here, and sphere plane. And I will actually just add another variable, a boolean variable right here. I don't know, call it up or whatever, and I initialize it to false. So this is a default parameter, and if this default parameter is true, I will only make this go up to the hill stuff then. If this is false, then I just stick with the norm, so stick with whatever we had earlier, so this algorithm right here. So I just make an if right here, if this up variable, which I should put right here in the parameter list, in the end, so bool up. So if this up variable is true, then I do a new thing. If this false, then I just stick with the old thing. So else, I just handle the collision as you would normally handle the collision. This goes into there. Okay, so this ray plane opens here, and it should close right here. And we return true where, so we should close this up right here. So if this up variable were true, then we are doing the new collision stuff. Basically all I want to do, actually let me open up GIMP and show you, is that I get a vector from one point of the plane to another point of the plane, so like this. Then I get the same vector, just set the y coordinate to 0, so I get a vector which lying on the xz plane, right, like that. I normalize both of these because the dot product needs two normalized vectors, and basically I do the dot product between them, and the dot product will give back the cosine of the angle. So this is the angle, then the dot product will give back the cosine of this angle. And we know that the cosine function looks something like this. I'll show you in a moment. So this, about this. Okay, so if we just set a specific threshold after that, for example, if this number, so the dot product is 0.9, 1 is meaning that there is 0 degree between the two vector, and 1 meaning there is so 0 meaning there is 90 degree between these two. So for example, if I get 0.9, that's about, I don't know, 20-30 degree of the difference. So what can I do is basically, if it is greater than 0.9, so for example less than 30 degree the angle between them, then I, instead of using the vector, so usually when we do something like this, we do it like this. So this is the normal vector of the plane, right? So if there is a sphere here like this, then I will move the sphere according to this vector, the vector which is the normal vector of the plane. So the sphere will be here, if you remember from the collision tutorial. But if the angle is greater than 30 degree, then instead, less than 30 degree, then instead of using the vector from the plane, I will use another vector which pointing up. So this is just simple, the 0, 0, 1 vector, and I move the sphere upwards. So this will basically do that the sphere will remain into the same place, basically. So I need to get a vector on the plane. Actually, I will get two vectors on the plane. So the plane look like something like this, and I need to get, for example, this vector like this, the horizontal one and the vertical one. For example, although I will actually get the diagonal vector right here and another diagonal vector right here, and I will determine the angle from the main plane, so the xz plane. So vector 3D, and I call it diagonal 1, and this diagonal 1 will be the, let me see what parameter do we get. For example, the p4 minus p2. The rejection doesn't really matter, so p4 minus p2, and another vector, so vector 3D, this is the diagonal 2, and this will be p3 minus p1. So basically I just get two diagonal vector with the endpoint minus the start point. This is how we get a vector. Right, then I need another vector which is actually lying on the surface, so vector 3D, and I call it reference. And this reference will be the same as diagonal. This is reference 1, for example. This is same as diagonal 1, except I will change the reference 1.y coordinate into 0. So the second vector will actually lying on the xz surface. So basically by changing the y coordinate to 0, it will not have any y coordinate. So if the original vector look like this, then by changing the y coordinate to 0, it will now look like this. Okay, so we can get the angle between the two. Right, and I need another reference vector for the other diagonal, so vector 3D and reference 2. And this will be equal to the diagonal 2 and diagonal 2, and set the diagonal 2.y equal to 0. And as you may know, we need normalized vector for the dot product to work correctly, so just normalize all of the vector. Diagonal 1 dot normalize, then diagonal 2 dot normalize, then reference 1 dot normalize, and finally reference 2 dot normalize. Okay, so we have the two vector. So now I only want to do is basically get the angle between them, so the reference and the diagonal. To do that, I will use the dot product. So float d1 like dot product 1, and the d1 will be equal to diagonal 1 dot product. This is the dot product which we have defined in the vector 3D class. The dot product is basically multiplying together the corresponding components, so x components and y components and z components, and add these together. Okay, so diagonal 1, reference 1. Similarly, I do it with the other diagonal. It's not necessary to do it with both diagonal, but actually I will do it with both, so the result might be better. Okay, and here what comes is basically I have to check the angle. So if the angle, so the distance 1, or d1, not distance 1, is less or equal than, for example, 0.9, and the other diagonal as well, so less than equal 0.9, that's pretty much mean that the angle is greater than Arcus cosine 0.9, which is, I have no idea how much, I believe 35 degree maybe. You can easily find out by running the calculator and just calculating the Arcus cosine 0.9. Okay, so we have the 0.9 right here. That pretty much means we have to use the old calculation because the angle is very great, so I just copy this old calculation code right here. Else, if the angle is less than 35 degree, I will just say it's 35 degree, I don't know how many, then I almost do the same thing, actually almost do, so let me just copy this because I almost do the same thing, except I will not use the normal vector of the plane, but I will use the normal vector which is pointing upward, so 0, 1, 0 normal vector. Okay, and I just basically set it to 0, 1, 0. And as you can see, we're multiplying by 0, so we can pretty much delete these parts, because multiplying by 0 will be just pretty much 0. Alright, that was it actually, and if everything goes correctly, this can be compiled right now and run. So let me just go into the project folder, FPS game 1, and try to compile it. Okay, with this. Welcome. Alright, so I opened up the object loader and we will do a few bug fixes in here. For example, in the load we have to set these flags which are here in the object loader. This is material, is normal, is texture and is vertex normal, all to back to false actually, except the is vertex normal. So I set these all back to false because I originally set these to false in the constructor somewhere here. Constructor. Anyway, yeah, here it is. As you can see, I set all of them to false as default, but whenever I load multiple models, one model may have a material and texture, and the other model don't have a texture. So to fix that, I just simply set these all to back to false whenever I load a new model, so false, and I will determine if this new model has actually a material or not, and this has a normal and not, and texture or not. Right, and another one which is very important, some models actually have partially textured and the other part is not textured. So for example, in case of, I don't know, human model, maybe the human actually itself is have a texture, but for example the sunglass has just a simple color. In that case, this object loader as it is will actually crash. To fix this problem, I just go here wherever I render the faces, so here, and I check if there are texture coordinates. So if and faces I, this is the current face, text chord, these are the texture coordinates. If you remember, I use text chord right here in the face, right here to store the texture coordinate. And basically I just check any texture coordinate, and if it is 0, then I just make is texture equal to false, else is texture equals to true. That's because this texture coordinate, actually if I come here, so wherever I push back the face itself, so this is here, if there were no texture coordinates, I just push back zeros as all of the texture coordinates. Right, so this will just eliminate if there are some parts of the texture, some part of the model is actually textured and another part is not textured, then it will basically turn off and on the texturing whenever is needed. Okay, and another thing is in the load texture function. One change is obviously we need to include the new load texture function, so let me just copy that. So here it is, this is the new load texture function which can load any format as it is. And let's see if we need to change the file name, because that's the only thing that could be changed. img.load, yep, we need to change it to file name, and I think that is the only change we have to do in here. And actually one more thing I just realized, a little bit of although it's work, but it doesn't have the best performance, the best memory usage if we use it for animation, because for a 100 frame animation we would always load the same texture over and over again, 100 times load the same image. Obviously that's a problem. So what can we do? Is basically remember what texture we already loaded and only load texture which we have not loaded yet. So let me show you how you can do that. Here there are the textures as an unsigned integer, and let me create another vector in here, vector, and this will contain string, and I just call it texture names. Okay, the texture will store the texture coordinate, and the texture name to the same index will store that the name, what was the name of the texture. So here when we actually load the texture before I return, let me just push it back. So texture names dot push back, and I just push back the file name. Right, maybe a conversation might be necessary, although I think the default so the constructor will take care of it, but anyway I just convert it to a string, and now the texture name contains the string. And here in the beginning I just go through all of the names. So for int I equals 0, I less than the texture names dot size I++, and I try to find the current names. Okay, so if the texture names I is equal to the file name, then I just return with the texture I. That's pretty much it. And do I push back to the texture? No, I have to push back the ID to the texture as well. So texture dot push back, and I just push back the texture. Wait, texture, that's not good, this is the same name. Texture names. Okay, we have to change this texture to some other variable name like A, and A here as well. Right, so this is the only change I do in here. So basically what I do is go through all of the loaded file name, and if we already loaded this file, then I just return with the ID of this image. So I don't load it again and again and again, but instead I just return with the already loaded image ID. And here, before I quit from the function, I just push back to the texture name and put to the texture the file name and the loaded ID. This is all change necessary in here, and let's try to compile it to see if it is actually compiled or not, if it is actually compilable or not. Of course, is texture, because I called it, what did I call it? Is texture without capitalization. So let me go back here where I changed this, is texture without capitalization, and I just realized we have to include the SDL image header file. So include SDL underscore image.h. Okay, and now if I do it and with the LSDL image flags, so LSDL underscore image flag, then this should compile and the images should load only once. So if we find a loaded image, that will not load again. And let me try to run it just to see if it is not crash. Okay, it does not crash, so I guess it will work because it's quite simple. I don't think that I make a mistake in this one, but later on when we actually include the animation, we will see. Alright, I open. Let's add multiple spawn points and also continuously spawning zombies. So I plan that with the OBJ loader, I'm going to load in a collision plane which has the ID 200. So right here, wherever I create the collision plane equal to collision plane, I go through all of them. So for int I equals 0, I less than cp.size, I plus plus, of course caps lock. So I go through all of them, int I equals 0, I less than cp.size, I plus plus, and then if the cp.cpi.id is equal to 100, because that's just a number and that will be the number of the collision plane, then I will remove it from CP and add it to the spawn points. So spawn points dot push back, and I push back a vector 3D, if I remember correctly. The spawn point is a vector 3D. Yep, I push back the first vector, the first vertex of this collision plane. So cpi.p0. And also after then, also I put the spawn point equal to sp before I do that. Right, and I remove that from the cp. So cp.erase and cp.begin plus I. So now the spawn points can be set from the image from Blender as well. We don't have to find it out where do we want it. And in the zombie.cpp, and actually, do I have a get spawn points? Let me make a function which get a random spawn point, just for fun. So int, and it will, and actually it's a vector 3D, and get random spawn point. Okay, and this will just pretty much return with a spawn point. So I generate a random number between 0 and the size of the spawn point. So spawn points dot size, and I call it, I don't know, call it I, whatever, call it I, and this will be equal to this, and then I just return with the spawn points I. So this just return with a random spawn point, and this is inside the level. I will put that into the header file momentarily. Okay, and get random spawn points level.age. So this will return a vector 3D and get random spawn points. Actually not points. Right, so it will generate a random spawn point on the map. So there we can put the zombie. Okay, in the zombie I'm going to make a died variable. So this will be uint32, and I call it died, and we will delete the zombie if it is died a long time ago. So here in the zombie.cpp, wherever the zombie dies, so the health is less or equal than 0, I just set the died equal to the current time. So get ticks. Perfect. So it died ticks ago, and then here somewhere I made a new function actually, and I call it bool should disappear. And this should disappear function, and this should disappear function will return true if we should delete the zombie, so make it invisible. So, and this is a bool zombie colon should disappear, so return with the current time as the get ticks minus the died. Actually we should use if is dead, so is dead, so if the zombie is dead and it is died longer than, for example, 5 seconds ago, so 5000, then I just return with true, as I will return with false. So if this should disappear return with true, I will just delete the zombie from the current vectors, like in the update function. So update, and I just go through all of the zombies again. So for int I, or I can use the for loop which I already have here. I go through all of the zombies here, and I add another if statement. If zombies I dot should disappear, if the zombie should disappear, then I just delete it from the zombies vector. So zombies dot erase zombies dot begin plus I. Perfect. So the zombie will disappear after a time. Let's actually try this out because I'm not certain it will work. So let me just go to my desktop and FPS game _1, and let me just compile this. Okay, it seems that in the collision plane I made a little mistake. I thought that I have tested it out, but obviously I did not. Here I have added an int ID. Okay, and let's see, 130 in the obj loader. Let me open that file up as well. So obj loader.cpp at line 143. Right here, 143. The problem is that I forget the semicolon after the loop variable. Let's try it now. In game.cpp at 210. So let me go here to the game.cpp at 210, and zombies I is actually a pointer. Alright, so let me actually try to kill this zombie right now. I will run the program and we will see if it is disappear after 5 seconds. So okay, it is died, and let's wait. Indeed, it does disappear. Perfect, this one is actually working, and let me just make the speed back a little bit. It's way too quick. So right here in the player, I just change the speed back to 0.5 and 0.2. Okay, I have this, and then now spawn continuously zombies to random spawn points. So let me get here into the update function, and if the random number 100, actually make it 200, is equal to 0, just if we generate a random number between 0 and 200, then if we get 0, so it's pretty random, then I will spawn a new zombie. So zombies.push back, and this actually let me copy whatever I have here. However, I created the new zombie, and also we need the animation. As I said, it's not the most efficient way, but I have an enemy frame. We added that enemy frame in the networking tutorial, so this enemy frame is containing the animation. So right here I just push back a new zombie. I think we need one more. Okay, that's right, and I just set this enemy frame. We don't have to worry about the sun because it will not load again, just the ID will be given to it. So I spawn a new zombie, and actually we should get a random spawn point. So the position of the zombie is actually right here. So get a random spawn point first. Vector 3D random spawn point, it will be equal to levels for now 0 equal to so get a spawn point from that. So get random spawn point, and this will generate a spawn point, and RSP sp.x Actually, no, we can just pass our FP here. Okay, and let's try this one out as well. Okay, and all L right here in the levels, and enemy frame was not declared. This is because I think I have used not capitalized F. Let's try it again. And let's run this. Okay, let me kill this one, and let's try wait if there is another one. Oh, there is one more. If we decrease this number, actually we only need to get the spawn random spawn point if we are going to add a zombie, so we can put that inside this if maybe it will have a little better performance. And let me decrease this number to 100, so it will add a zombie more often. And now if I run this, then we will have 2 zombie, 3 zombie, and we get a segmentation error, so we screwed up somewhere. Cool. Alright, I found it in the zombie.cpp file. Just set the current frame equal to 0 because apparently this was a not initialized variable, and I'm not sure that why the current frame doesn't set back here in the update function, but for some reason it did not, and that caused the segmentation error because we wanted to access a place in the frames array which doesn't exist. Alright, and now that it is fixed, oh, I know why, because here after the random the show was called before the update of the zombie. Now that it is solved, it actually working. Let me show you. Here, as you can see, 1 zombie, 2 zombie, 3 zombie, 4 zombie, they are coming. So as you can see, there are a lot of zombies, an entire army of zombies following me, and let me massacre all of them. Cool. Now this was about it, so let me see if there is let's add multiple spawn points and also continuous. I have opened up a few files and we will going to take a look, another upgrade to the collision system. Now some of you may have already noticed that if you change the speed to a little bit higher value, like let's say 2.5 and 2.2 right here, wherever I create a player in the game.cpp file, and if I run it right now, alright, so if I run it right now, I can go through the walls. So let's see, as you can see, I gone through the walls. Now why is that? It happens because your wall is right here. Let me draw a wall right here. So here is your wall, here is your sphere, and the sphere goes that quickly. So like in the next step it's here, and then in the next step it's here, that the center point is already over to the other side of the wall before the wall have actually chance to push the sphere back. So what you could do is make smaller moves. So instead of moving every step by the speed, so like moving every step right here, as you can see from here to here, instead you make small moves. So let me demonstrate that by making, for example, 3 more moves. So in that case you move here, and then you move here, and then you move here, and then you move the final position. So basically you do 3 additional collision detection steps, and in this case if the wall is right here at the center, you would have noticed that and not go through the wall like we did in the first case. So how could you achieve that? It's not that complicated. Although we need to modify a little bit this camera.h header file, and now instead of moving the camera, actually we will just give back how much it should move. The rotation still remains in the camera class. So the control function will now give back a vector 3D object, which will be basically how much the camera should move. And then in the camera.cpp, in the move camera and move camera up function, again we modified these as well. So let me actually add here to the prototype that we give a vector 3D reference right here, and I just call it new position, and again here as well. So vector 3D, and let me actually call this new position. New position. Okay, and this new position will be basically give to this move camera and move camera up function, and instead of the move camera actually moving the camera, it will just give back how much it should move to this new position vector. So let me get here into the move position move camera and give back here to as well. So vector 3D new position. Right, and let me just copy that to the move camera app as well. So here, instead of using location.x minus equals sign, so whatever in here, I will do it with the new position instead of the location. So I can just copy this new position right here instead of the location, and again the new position right here as well. So this was simple. And then in the control function, I will actually pass another vector right here. So let me create a vector, and this vector will be, let me make it here outside of this if statement, vector 3D and new position. Okay, and the default constructor will just define it to 0, and then let me pass it to the move camera function. So new position. Okay, and let me pass it to everywhere. So new position, here the new position, and new position, oops, almost. New position, right. So this new position now contains how much the camera should move. And then in the end I will just return with this new position. That was all modification needed to do in the camera.cpp header file. And of course we have to change the void to a vector 3D because we will forget if we don't do it right now. Alright, now the next modification in the game.cpp in the update function. So let me go down here where we update everything. And here where we call the control function, actually we call it in the show function, camera.control, here it is. I get a vector right here. I just call it vector 3D and again call the same name, new position. And this new position make it equal to whatever we return from the camera. So now this new position contains how much the camera should move. Now we should pass this to the player update function, although we have to get the update function to the show function, although update function should be in the update, but I have to move it right here in the show function to make everything working in the easy way. So right here I put the update function, and the update function should get how much the camera should move. So let me get here in the player.h file, and in the update function right here, update, I just add another variable which we are going to get, so vector 3D, and this can be a const vector. So called vector const, let me put it a const vector 3D, and this will be the new position. So now we pass the new position into this update function. So let me get into the cpp file. Right here where the update function is, I get this new position. So here, new position, which is a constant vector 3D reference. Okay, I got the new position right here, so we know how much should we move. So now let's make the direction equal to this new position. So direction equal to the new position. So now this direction contains where should we go. And then we add the gravity as well. We are almost there. One last thing is remaining, is to use a for loop, another for loop in here. So for int I equals to the number of checks, so actually 0, and actually let me call it j because we already have an I. So equals 0, j is less than the number of checks, and let me make a variable for that or not, it doesn't really matter. Make it 5, and I plus plus, j plus plus before we get an infinite loop. Okay, so right here, this small little segment that is doing multiple checks. So instead of checking all the collision plane once, it will check all the collision plane 5 times. Although that's not all we have to do, because as you can see, we have to move the sphere a little bit. So for example, if we have 5 steps, we want to move the 5th of the whole distance, and that's actually it. So here the new position, which as you can see we check, the new position plus equal, and the new position plus equal the direction divided by the number of checks, in this case 5. Let me make a variable for that, int num check equal 5. Okay, and here num check and here in the division num check. The higher its number, the more precise the collision detection will be, and you can detect collision the more higher speed, but of course it will slow down. Another method to achieve the same effect will be to do a ray tracing and then get the distance from the ray tracing, and yeah, that's you get the idea. So every time I go only fifth of the whole distance, so after the 5 loop obviously I get in the same place. But if there is some wall between the two, then I can already check if there was a wall, because I did 5 check, so I check between the two, between the two sphere. So you get it. Right, and here in the game.cpp, and did I move the position? Yes, that position. Here I move the position. So I'm pretty sure that's all change we have to do in the player.cpp. So let's finish up with the game.cpp by passing the new position right here. In order to pass that, we have to call the control function before the update. And then here just pass this new position which I have created. Almost there, but one problem is remaining, that the show should have an identity matrix. So whenever we render the weapon, that weapon should have an identity matrix. So let me go to the player.cpp and in the show function, and let me just load the identity matrix. But in order to not screw up the transformation which we have already created with the control function right here, I actually push it to the matrix. So gl push matrix, push it to the stack, actually not matrix, and then load the identity matrix. So gl load identity, and finally we just pop it from the matrix, and I'm pretty sure we are ready. gl pop matrix. So let me try to compile it actually. So get a terminal right here and compile. Alright, it seems to be compiled without any error, which is rare. And now I can still go through the walls. Maybe if I increase the number of checks right here, that will fix the problem. We will see. So let me make 20 checks. That's a lot of checks. That should fix the error if we did everything as we should have done. Or not. Alright, the problem was actually that this I forget to remove the last new position plus equal direction. So now after I have removed it, and actually I set it to false, I get back to that later. So now that I have removed, 6th check is perfectly enough. So if I run a program in the current state, as you can see, I can go relatively high speed like a airplane and still cannot go through the walls. As you can see, even 2.5 speed. So I guess it's working right as it should be. So that was this part. So let me get back to the sphere plane, because we screwed up something there. So collision and sphere plane. I will check. I have opened up. I think this little code segment should solve the issue. The issue is actually that the wall is completely vertical, so there are no so it's not 98 degrees or 89 degrees, but it's exactly 90 degrees. And in that case, this is what we did here, is actually not determining the vector to the top, but actually determining the vector. So let me show you in GIMP. While normally we have a wall like, for example, this, in that case I have a vector which pointing to here, and another vector which is pointing here, so upward like that, and then I can get the angle between them. But if the wall is completely vertical, then I have no vectors in the x direction, or more precisely, if the wall is looking like this, I have a vector in this direction here, and I have another vector which is in this direction, and also I can get the angle between them, but the angle is basically determining how tall that is, so whatever we put in here, and of course that is a bad thing. So but if there is some angle between them, so it's not exactly vertical but something like that, then it should work as we expect. At least I think so. So like that, and we can get the angle. So this little line segment which I have added basically get a vector, so a horizontal vector. I get this element right here and this bottom element, and I get a vector which pointing to from one to another like this, and basically I dot product that together with another vector which pointing up, and if the angle between them is 0, then basically I get a number 1, and I represent it with 0.999 and make it equal to this vertical, and I'm pretty sure that this should solve the issue, although I'm not quite certain, but I'm pretty sure. So we will test that out later on. For now, I think this as the last coding step, let me add just one thing that the player will, so the player can die, because now the health of the player actually decreases, but it's never die. So I will just quit the game for now, so just setting this running equal to false, but of course you can free to implement, I don't know, respawning or going back to the menu or something. So here, before I call the update, I will just do one line: if player 1 and I get health is less or equal than 0, then I just set the running equal to false, indicating that we are quitting from the game. And that's all we have to do in here, just to add death to the player. I'm pretty sure we can compile this. And run it. And let's try to die, which will not be too hard. I've already died. Oh, here is it. So let's go into the zombies and die. That was quick. Maybe we need to add a little bit more health to the player, because these deaths are kinda quick. So here in the player constructor, I guess in the constructor, or did I hard-coded this value? Health. No, I hard-coded this value, make it 1000. And of course you can implement medkits or something. But this was the last coding step. I will try to cut this one tutorial together to something which makes sense, and then in the last tutorial I'm going to make the modeling. Okay, seems to be working. Thanks for watching, and have a as the last coding. Now what we could also do is change a little bit the OBJ loader. We already did some changes in the OBJ loader, like using the new load texture function, but actually another change which could be very useful is not to load only materials like collision named material, exactly collision named material as collision planes, but also load something material like collision and a number like 1 or collision 2 or collision 100, and that number could be used as an identifier. So what will we identify with it? Anything we want. So for example, in case of the other game I made, not other game but actually modification of this game, is I use this number after it to determine which surface I am going on. So for example, collision 1 determining that it is a grass surface, so I'm going to play the grass sound whenever the player is walking. 2 mean it's a sand surface, so I play the sand sound, and so on. Or another example, as you have may saw, that I try to implement using collision planes as the collision detection for the zombie, not a collision sphere which is too big, and I end up with it's kind of working, kind of not. It can determine if it was a headshot, chest shot, arm shot, or leg shot, but for some reason I can't identify. It some reason give even the shots which are next to the collision planes. So I will upload that source code if you can take a look. So anyway, if I write 100 here, that means it's the head of the zombie. So if I use a collision detection and I end up with a collision plane with this ID 100, then I know that it was a headshot and I subtract more health from the zombie than I would normally do. Okay, to achieve that, it's a very simple modification in the OBJ loader. Right here, where we compare the material name with collision, let me just search for that, collision. Alright, right here I compare the material name with collision. I will not use the strcmp but strncmp, which is the only modification. It's not examining the exact so it's not examining to the end of both string, just the n characters long. So if it starts with a collision, basically I can tell that by actually counting how many characters there are in the collision word. So 3, 6, and 9. So I just pass a 9 here. And in this case, I pass it to true, but I will also read in the number after it. So how can I read in the number? There are several ways, of course, but I will just use the same method as I did in the networking tutorial. So with a while loop, go until go as long as I find numbers. So I just make an int id and make this id equal to 0 at the beginning. And while and make also a loop variable, call it k or anything, and this k will be 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. That's what I wanted to do. And while the length, so strlen tmp is less than k, actually it is greater than k. So I don't, or let's write k is less than the length of the string. And the next character is number. So tmp k is greater or equal than 0 character and less than or equal than 9 character. So k less or equal than the 9. That pretty much means while we are finding characters, then until I basically convert that character to a number and add that to the number. So id multiply equal 10, and then id plus equal the tmpk minus 0 character. So you should already be familiar with this, I guess. But basically, if I have a number 123, first of all it will get the number 1 and push it back to the id. So first of all I multiply the 0, which is the id at default, by 10, which is 0, add 1 to it, so it will be first 1, and then I multiply it by 10 again in the next loop, 10, and then add 2 to it, so 12, and then I multiply it by 120, and I add 3 to it. So this is how it is working. And the next character is not a, and of course increase the k, and the next character is not a number, so in that case the loop will stop and we end up with the id. So let me just write out stdcout I've read an id, and just write out id for debugging purposes. Alright, and actually let's make this id into here, so I can access that from other places, right here. Okay, and this id can be -1, or yeah, you know what, let me just do it back. Okay, so here I am, and std, and now I can make a variable right here somewhere in the load, so not in any so in the function scope. So let's make an int, and I call it, what should I call it, material id, and let it make be -1 at default. And now we can use this material id whenever we have a collision plane. So right here, when I determine if it was a collision plane or not, whenever I push back the collision plane, I will add this material id to the end. We will modify the collision plane momentarily. So material id, perfect. Now we actually finished, almost finished. Let's make the material id equal to the id. Material id equal to the id, and here let's just make the material id equals to -1. This will cause that the id for the material will be -1 unless we read the number. So we can read the collision material without any numbers too, but in that case the id will be -1. Okay, so let me open up this collision plane file, here this 2 file, and modify, add one more parameter into here, int id, and actually let me make it defaultly -1 because we use this collision plane a lot of places, and I don't want to modify everywhere to add a -1 id, so I will just make it default. And actually I should do that in the header file. So int id equal to -1, and I also create an id right here in the collision plane, so int id. Okay, and then in the C++ file I just use this id equal id. Perfect. That was all modification which was needed, and yeah, that was pretty much what was needed. And later on you can use this ID to identify something, not just the sound, but anything you want to identify. Like I said, I used it for determining if it was a headshot or chest shot or something. You can easily access to this ID by using the collision plane and then the ID, because this is public. and then you can do things according to that. And so far it was a normal tutorial from me. A normal, it's kind of weird, but I just typed it. But from now on I will not type anything, but I will show you how I did it in my other files. That's partially because the rest of the stuff is kind of simple, so it's not that complicated, and the other part is because I don't want to type that much, and it starts to get boring. So let me just show you. I will open up my other file. Here we go, and let's see what else change did I make. In the camera there was no change, collision work exactly the same, and collision plane I have added this ID, collision field remains the same, enemy 2, and right here grenade class, it was requested, and basically I wrote it very simple. If you already did some similar class, actually we did a lot of similar classes. First of all, I have a few flags like active, exploding, and ground. These are obvious. What is it? Is active become true whenever you actually throw the grenade. Exploding will be true whenever the grenade is exploding, and is ground is true whenever the grenade actually hit the ground somewhere. I use a mesh, so it's basically a simple sphere which is green. The force is basically the force which is currently there are in the mesh, so basically the gravity and so on. Position is obvious. Time is the time whenever it become active, so we can determining the when it will going to explode. For example, set it to 5 seconds, and just determining the current time minus the time is greater or equal than 5000, then we will explode. Strength obvious, radius is needed for the collision sphere. Okay, I added a particle system. I will talk about that momentarily. And the functions are pretty common. So I have constructor, destructor, update, show. These are basically in my every class. I could make a common class and inherit all of this stuff from there. The get position and drop grenades, actually everything else is actually obvious, except this why is the show particle system is separate. That's actually because, as you might remember, we should always render the transparent objects last, and particles are transparent or semi-transparent, so we should render it last. If I would to go into my game.cpp file right here, you would see that in the show function, right here in the show function, a little bit up, right here in the show function, the particle systems are always in the bottom, as you can see. That's because, as I said, we have to render it last, as we would have weird effect, and we don't want weird effect. Okay, the CPP file, the constructor, I just set everything. The destructor, I just delete the particle systems. I will talk about particle system in a moment. And here I just use an if, as, and if. So a few if statements to determine if we are drop the grenade but it's not exploding yet, then actually this time is not actually the activation time, it will be subtracting. That doesn't really matter, it will work on the way I said it to. Now if it is less than 0, then we are going to explode, we are going to blow up this grenade and start a particle system. So that will basically the smoke and the fire which comes out from the grenade. That will be the animation. There will be no animation like we did earlier, so with a vector and the for loop. And then I just go through all of the zombies and determining how much health should I subtract from their health. So first of all, I determining if it is closer than the, so here I just determining if it is close enough. So basically I put a value into here, 30. This is the radius which will affect basically everything, for example the zombies. And if the sphere collision detection return true, that means the zombie is within 30 units from the grenade, then I will subtract some health from the zombie, and this is basically the equation which I use, formula rather, to determine how much health should I subtract. So I divide 30 by the length multiplied by strength. So what I resulted is the closer the zombie, the smaller this number will be, the higher this first part of the formula will be, and then I multiply it up by strength. It just seems good, it can be any number. The next is the is ground, is basically, so if it is not is ground, it's not on the ground, then we are basically just applying the forces to it. And then I just go through all of the sphere, all of the planes, and determining if it is actually hit the ground. and is exploding is obviously true if it is exploding. In that case, I will update the particle systems. Okay, that was about it. And whenever the particle system become inactive, I will talk about that later, then it will become false, so it's not active anymore. We don't have to update it. The show function is pretty simple. If the grenade is active, then I just go to the position of the grenade and call the mesh, so basically drawing it out. Show particle system is just as simple as updating the two particle system, which I'm going to talk about. The drop grenade is making the grenade active, and then the direction times multiplier. So direction is where the player is looking at, and multiplier is just a number to make it stronger or less strong. So for example, if you hold the G key longer down, then this multiplier can be bigger and make the grenade go farther away. Okay, and the location is basically the player's location, and first the grenade location will be equal to the player's location, and a few getter functions. So it is a pretty simple class. There is nothing too much to explain about this. Let's see the next one. So let me get into here, not here, but the other folder here. And let's see, grenade, I talked about that. Item, we made that. Knife. Knife is another class, which actually I made a tutorial about it, but I wasn't sure to upload it or not, so actually I ended up not uploading it because it was too boring. I think that I have deleted it accidentally, so don't request to upload that. Right, so there are a few member variables which are kind of obvious, like the mesh is knifing, strength, the delay and the weapon delay. Delay is the delay between two knifing, and the weapon delay is the delay because the delay to get the weapon again to the player's hand. So what happens is whenever I'm knifing, I will set the player's weapon not active, or with what I call it is visible or something. So I will basically not show the weapon, and the player obviously can't even use the weapon while knifing. And this weapon delay will give back how many frames should it elapse until the weapon can be the player's hand again. The last knifing is obvious. We needed to determine these two delays whenever they need to be updated. Okay, the location rotation is simple. Basically all I do is render this mesh out if obviously the player is knifing, and rotate it 180 degrees, and then set the is knifing back to false. Okay, the member functions, again, it's pretty straightforward. This test is the same as in case of the weapon, so where should you put the knife? You can determine it with that. Okay, and here the strength. So here in the constructor you do not do anything special. The set knifing. So first of all we have to determine if we can knife again. So the last knifing is greater than delay. For example, if we can knife in every 30 frames and the last knifing happens 40 frames ago, then we can knife. Then I make the hold weapon, not right here, but somewhere I do. Anyway, so I think this doesn't matter. Okay, so the last knifing I make it 0 because we just knife it right now. Make the knifing to true, and then basically I just go through all of the zombies and do a ray sphere to determine how far away are they. And if they are far away, so again the ray will be actually the player's looking direction, as you can see right here somewhere. So here this vector x, y, z is the player's position, vector and location, I guess so. So I do a ray tracing with the direction where the player is looking at and get all of the zombies, and if some zombie is close enough, I use 16, but probably it can be a smaller value, then and of course the zombie is not dead, then I can decrease the health with the strength of the knife. Okay, the update function is basically set the last knifing, so increase the last knifing because a frame has been elapsed. If the last knifing is greater than the weapon delay, then I just return with 0, indicating that the player can hold the weapon again. I will show you the player in a moment. And if knifing, and if we are knifing, then I just rotate the knife. That is it. The show function is pretty straightforward, and the rest of the functions are. So this was the knife. It's pretty simple class, and we have a few more. So right here in the I have added a matrix. You don't really have to know about this one right now. It's just a simple matrix class which is implemented the most important functions of a matrix, like determinant and inverse and so on. So just I just show you the header. It uses an vector, which is not really need to be public. The only reason it is here so we can use the normal matrix operation. So we can use the same way the matrix, like through two of the square brackets, like we would normally use a matrix. And then I make a array of this other array, so it will become a matrix. And these are the operations I have implemented. This is not really needed for this game actually. I have added this because of that collision detection, which is apparently not working, so I will not show you that either. Okay, back to the business. Network, I have said, object loader, particle system. This is it. This is a third and last of the new class which I have made. Particle system is, if you have seen my 2D tutorial about SDL, it's pretty similar, except we are obviously moving in 3 dimension. So what are here? We have a particle, which is just a simple particle inside the particle system class. The particle has its position, rotation, and speed, start, and so these are pretty straightforward. What are these? And the lifetime is how many frames it can be alive, and created when it was created, or maybe I use milliseconds, I'm not sure. Okay, the constructor for this is, as we would expect, fill up all of these parameters with a lot of parameters which we have passed into here. The update is pretty much just moving the particle by adding the speed to the position, and the show will just show one particle. Okay, the particle system is containing a lot of particles, and we have position of the particle system, number of particles, and a lot of other crap. And these are pretty straightforward. I made a few variables like start color and end color. What I am doing is basically get the that when your particle is created, it will be start color colored, and when the particle is destroyed, it will be end color. So, and between them, it will do a slight interpolation. Similarly with the size and speed. Right, okay, so here I just added a few functions. It's pretty straightforward again, what each of these functions does. Let me show you the C++ file. So here the update, here the default constructor basically just set the last update equal to the current time. So we will know how much the particle should go. Okay, so the two constructors are simple. The update function, we first of all calculate how much time has elapsed since last time in seconds. Then move the particle with that many units. So we don't actually just add the speed to it, but actually determining the delta time. It can be useful if you are not using fixed FPS, but actually the FPS change, because for example if it is running very slow, then this number, the delta time, will be big, so you always get basically the same number of steps, so the speed will be always the same. By the way, this particle system, I'm going to make a tutorial about it as an OpenGL tutorial, so I might explain things better there. Alright, and as you can see, we decrease the lifetime with the delta time, and then we set that it is currently updated. We set a percentage, which is basically how much the ratio between the lifetime and created. So it will be basically a number between 0 and 1, wherever 1 will be that it is just created and 0 will be that it is destroyed. And then I do a simple interpolation between the start and end color. This is a pretty common way to do linear interpolation, by just getting the percentage of one color and the 1 minus percentage of the other color. If it is dead, then I just make it dead. That was the update function, so you mostly have to know about this color and how to update position. The show function is pretty much just getting the current color. I use the floating point number, so I have to divide by 255, and just drawing out a rectangle right here. And I also changed the alpha channel. As you can see, the last parameter is the alpha, which is again the ratio, so it will start to be completely visible and then go to transparent as it gets closer to its death. So it can be better to simulate fire. Alright, the next is creating the particle system. Here, whenever I create the particle system, I just set every variable to the logical order. So every variable is basically number of particles, dB, and so on. So it's pretty straightforward. We have made thousands of these. Then I generated the number of particles with the generate particle function, which is just generate a particle into particles I. And first of all, I push back a new empty particle into the vector and I generate one. The destructor doesn't need to destroy anything, the vector will take care of it. The generate particle, it seems very ugly, but basically what it is doing is set the particle's position to the same as the position of the particle system, getting a random number between the maximum and the minimum size. This is it. So it's a pretty common way to get the difference between the maximum and the minimum, get a random number between that range and add the minimum size to it. So it will basically get a number between the minimum size and the maximum size. This is how you can get a number in a range. And I do it with the speed and so on. So that's what this crap it is. Right, and the number of particles minus. The number of particles is basically how many particles should there. So this particle number is how many particles how many particles the particle system should erase of its lifetime, while this num-particle is how many particles should there be currently on the screen, so one time at the screen. This is the difference between the two. Okay, the update function is just going through every particle and update their position, and if one particle is destroyed and there are still particles, then I generate a new one. And if there are no more particles, so the num-particle is less or equal than 0, then I just set it to false. Okay, here in the show, first of all, I modify the model view matrix. So the first 3x3 part of this model view matrix will be the identity matrix. It's actually a little trick to make particle system to make cheap billboarding effect. I will make a tutorial about billboarding in OpenGL. Basically, it is all the particles will always face to the camera, because the particles are not actually just pixels, but actually little rectangles, as you have seen, and they should always face toward the camera. As for example, if they wouldn't face toward the camera, we would have a weird effect that the particle is not actually particle-like, but rectangle-like, and that would be very bad. And then if I have textures, then I just activate the textures and going through all of the particles and show them. And the rest of them is pretty simple and straightforward. So that was it about the particle system, and let me see if there is another file right here which I should explain. The player update the knife and the grenade, not the game, so it seems more appropriate that the player have the knife and the player have the grenade instead of the game. And I don't think that there is anything else in here which is new. So that was the modification which I did. Sorry that I didn't make a tutorial about it when I actually going through more deeply about it and explaining, but I really want to finish up this FPS series before in the summer, before the school starts. So that was about it, and in the next tutorial I'm going to do the season finale, let me call that for now, because maybe later on I will come back to this FPS game and implement more stuff like skeletal animation and so on. So the next is the final tutorial of the FPS game. Thank you for watching and have a